Hi all, this is Eric. In this episode, we're going to talk now about the code of the midnight examples. In the first episode, we learned how to run and how to install the midnight examples, and now we're going to go deeper and understand how this code works. The way we're going to structure this episode is going to be in 4 topics. The first topic, it's related to the architecture of the repository. We understand how to structure and how to build, understand all these APIs within. In the second topic, we're going to talk about the compiler and how this fits within the repository. In topic number 3, we're going to understand how the counterexample is structured. This counterexample, it's a basic example on how to use Midnight, but it's going to serve as a basics to really understand how are the different instances and APIs necessary to run Midnight smart contracts. Once we have that foundation, we're going to go to topic number 4, where we're going to see another example, which is the bulletin board example. This contract is more complex, and it's going to give us a better foundation to then start building other smart contracts. Related documentation, you're going to be able to find all related information to understand these episodes in these 3 links. The first link is related to the docs. If you go to midnight.meshjs.dev, you're going to find all documentation related to this episode and the other episodes that we are going to make. So if we go to that link, you're going to find this nice UI. So we are here in examples, midnight examples. And in the first episode, we talk about build and run the repository. And now in episode 2, we're going to use this one, understand the code. And here you're going to find all documentation related to the episode and links to the technologies that we're going to need to understand to build and work with smart contracts in Midnight. Then in point number 2, it's related where to find the code for this episode. So the code is going to be on GitHub, on the organization MeshJs, and in there, there's a repo called Midnight. So if we go over there, we go to GitHub, you see we have an organization MeshJs and a repository Midnight. In here, it's going to be all the code related to these episodes and other episodes in the future. Under examples, you're going to find all the examples that we're going to do in the future. And now we're going to see these midnight examples. So if we go into that folder, you're going to find all the information related to the episode. And point number 3, it's related to the videos that are the tutorials that we're doing right now. So they're going to be hosted in YouTube and are the ones that you're watching right now. Okay, so in this topic that is related to the architecture of the repository, we are first going to understand some technologies necessary to understand the repository, which are, for example, Monorepos and Workspaces. We're going to give an introduction on how this technology works and provide some links in case you want to go deeper into that technology. Another technology we're going to use, or library, it's Repo. This one is really important because it allows us to create automation processes within our Monorepo or Workspaces. Another technology or libraries we're going to use is Midnight packages. These Midnight packages are provided by the Midnight team and basically are ways to interact with the smart contract using APIs. So we're going to go deep into that technology and we're going to learn how to use these packages. Another technology or library, it's RxJs. This is basically reactive APIs or libraries using TypeScript or JavaScript that are important because the Midnight packages use them as well. So to keep things interoperable, we're gonna keep using RxJs, so we're gonna use these two together, and we're gonna use RxJs as well in our code, in our TypeScript code, to keep using the same technologies as the Midnight core team. Another technology is test containers. This one allows us to create instances using Docker within TypeScript. So we're gonna understand that technology as well. Okay, so now we're gonna understand what is monorepos and workspaces. For that, I have taken a picture of the repository. You can see it here in the left. So in this repo, we have a package.js. Within, we can see this configuration, which one of them is workspaces. This is where we define what are the workspaces that we're gonna work in this repository. In this example, we can see compact examples, examples counter, and examples bulletin board. Within each of them, you can see this symbol, which means please consider all the folders within examples. So in this case, if there's other folders inside examples, those ones are gonna be considered as workspaces as well. In this case, we are being more specific. We are saying examples counter and all the folders within counter, consider them as workspaces as well. So if we take a look at the left, we can see folders, which are compact, examples, bulletin board, and counter. Since we have declared them that these are workspaces, these are gonna be our workspaces, right? So if we look deeper into those folders, I have taken another picture on the right. You can see that within bulletin board, there's gonna be other folders. It's gonna be a folder called API, bulletin board, contract, and within counter as well, there's gonna be other folders, contract and counter CLI. Each of those are different projects. What I mean by projects is that within that folder, there's gonna be a package.js. This other folder has another package.js. So at the end, they have different meanings and intentions, right? So there are different projects. So let's answer the question, why monorepos and why workspaces in this case? So what monorepos and workspaces allows us to do right now here is that when we are developing this folder API and we want to use the code within in another workspace, we can actually do it, right? So we can use code in the API and use it in contract or in bulletin board UI without having to push them into NPM. So what happens normally is that, for example, you're configuring your code within API, right? You have your code, and if bulletin board UI wants to use that code, normally you would have to push it to NPM. And then, for example, in the contract project, you want to use some code from the API, you would have to install it and then use it, right? So that takes time, right? So with workspaces, there's no need to do that. You can actually just call the libraries from the API and push it to the contract without having to push the code to NPM. So that improves developer experience, and we are able to develop and debug things faster. Okay, so now we're gonna talk about Repo and how it connects with workspaces. So I have taken a picture again of the repository, and we can see that we have a configuration file called turbo.json. Within is where we configure the workflow of how the different workspaces are gonna install its dependencies and are gonna run the code, right? So we have here the configuration. Within, we can see that we define pipelines. So in this case, we have 3 pipelines. One is called type check, the other one is called compact, and the other one is called build. The way it works, first we're gonna run the pipeline compact, then we're gonna run the pipeline type check, and then last, we're gonna run the pipeline build. Why it works that way? It's because turbo JSON configuration, it looks at the depends on configuration. So that's where it says which pipeline is going to run first. So in this case, the compact runs first because its only dependencies it's on the build parents, which means build all dependencies and then you can go ahead and install and run this pipeline compact. If we see another pipeline type check, for example, we can see that it has two dependencies. One, it's the build parents, which means build its dependencies, and then build compact. And for pipeline build, we can see that we run its dependencies. It depends on compact and depends on type check. So that's why this one runs first, then this one second, and this one third. One thing that it's you should take in consideration and understand these pipelines is that each pipeline gets connected to one command in a package JSON. So we see here we have a pipeline type check, but also in package JSON we can see a command called type check. In compact as well, then within package JSON we can see a command called build. Compact. And then for pipeline build we have another command build, right? So let's take an example of one of the workspaces, right? Within a package JSON of that workspace, we can see dependencies and we can see scripts, right? So within a workspace, we first have to build its dependencies. Why? It says here, right? We have to build dependencies. It's parent dependencies. So this is where the dependencies command has to run first before even running any command within this package JSON defined on scripts. So to build this project, we have first to build the bulletin board API workspace and the bulletin board contract workspace. Once these two are built, then we can proceed and install this package JSON. So in this package JSON, we have these three commands. First, we're going to run compact command, then the type check command, and then the build command. Why? Because we want to follow the configuration of turbo.json. So first we have to run the compact, then type check, and last build command, the build command. So that's the way we create workflows within the Monorepo, and we define all dependencies and all scripts, and just by running npx turbo build, we can run everything in the correct order, and we don't have to worry about dependencies. Everything is controlled by this configuration. Okay, perfect. Now we want to understand what are those Midnight packages about, right? First, let's learn where to install them. At the root of the repository in the package.json file, we're going to list all the APIs available within those Midnight packages. There's a lot of them, and we're going to learn about them in the future when we analyze in more details how the code is structured. First, what I want you to learn is how these Midnight packages fit within the architecture when you develop smart contracts in Midnight. So for this, we want to analyze this architecture here, right? So it looks complex, but actually it's really simple to understand. I'm gonna guide you through this architecture. First, let's think about this Midnight tab as the heart of the application. This is where everything is gonna fit together. The dApp communicates with different instances. We're gonna learn about those instances in the future and how to install them. But we can see that we have an indexer, we have a node, we have a proof server, and all these instances, they communicate through the Midnight Lace wallet and talk with our application. On the left, it's down here, we have our compiler. So we're gonna learn about that in the future as well, how to where it fits within the repository. So now we want to focus on this first part here, my TypeScript.code. This is where all the API fits, and this is where we write our code. So this code is responsible to create the structure, how all these instances and how this code is going to communicate between each other, how the workflow is going to fit, and how we're going to develop these our smart contracts and our application. So right now, what we have Midnight's packages available. We can see here. In the future, we are planning as well to create mesh APIs. So this will come in the future as well to facilitate writing smart contracts in Midnight. Okay, now let's learn about the technology and library test containers. So before explaining test containers, we did this diagram. I want to let you know that I have left a link in the docs. So if we go to the docs, we're gonna see that we have a link for test containers. This is the official web page of this library. If we click this link, we go to the official web page, and here you're gonna be able to go into more detail about this technology if you want to learn about it. But at the end, what this technology offers, according to the author, it's define your test dependencies as code. So what does that mean? Let's go back to the diagram and explain it here. So before, we were explaining how Midnight app was structured, and we were mentioning that we have instances, right? We have the indexer, we have the node, and we have the server. All these instances are provided by Docker containers. So we're gonna use Docker to spin up those instances. Here on the left, we have our code, our compiler outputs. This is in TypeScript. So how do we integrate instances with TypeScript? This is where test containers come into play, right? So at the end, we write TypeScript, and within the TypeScript, we can give commands for these instances to do their work. So we can have commands to spin up instances, to shut down instances. So this facilitates a lot the developer experience when it comes to testing, and lowers the amount of boilerplate that we need to write for creating the environments for these instances to work and write along the TypeScript. Okay, another technology that we're gonna use, it's called RxJs. RxJs is basically a TypeScript library that allows us to write a reactive code within TypeScript. The main reason we are using RxJS, it's because one of the instances that we're gonna use to write smart contracts and applications in Midnight uses that technology, which is the indexer. So indexer uses RxJS, and that's the reason that we're going to use that technology to promote interoperability. If you want to learn more about RxJS, in the documentation, I'm leaving a link that points to the official webpage of that technology. And in here, you're going to be able to find detailed information about RxJS, where you can learn about observables, observers, operators, subscriptions, subjects. We're gonna see how to use all these entities of this library within our code in the future. But now I can give you a basic overview of how these different entities connect it's gonna connect in our applications in Midnight. So I'm providing this basic architecture. So the way it works, it's that the indexer is gonna emit values, right? It's gonna emit values, where an observable is gonna provide that information coming from the indexer. So this is what Midnight offers. It's an observable with synchronous information coming from the indexer. We're gonna write observers in our code. So the observer is the entity that subscribes to an observable. So the way it works is that when a new a new information coming from a smart contract, for example, from the indexer, gets into the observable. Since this observer is subscribed to the observable, we want to receive that information. We can write operators here as well to filter that information based on a specific logic. And if that passes, we can grab that data, new data coming from the indexer, and perform some specific functions or write it in an object. So with that, we conclude all the foundational knowledge that it is required when building Midnight smart contracts and the libraries necessary for that. So now in chapter 2, we will talk about the compiler. For that, first, we will talk about the compiler workspace and where is that position within the Midnight template repository. And then we will take a look on the code itself and how it is configured. Okay, so now we're gonna start seeing more code and configuration. So we're gonna go at a slow pace and we're gonna put a lot of emphasis in details so we can grab all the context related to what we're gonna talk about. Okay, so the compiler fits within a workspace. Midnight examples folder has different workspaces. One of them it's compact, where it's the compiler. That compact has a package JSON and some configurations inside. The name of this package, it's called Midnight Network Compact. And there is a command in here called bin, and inside an executable named run compact. So that's exactly what bin does. It makes this command be able to be run by other workspaces, considering that these other workspaces make compact workspace its dependencies. Okay, so now let's understand the code inside the run compact C file. There's a lot of boilerplate within this code, but at the end, this can be summarized by taking a look at two lines of code. First, this one here, let compact path. Basically, we are defining in this variable where it's the binaries of the compiler. In the first episode, we have learned how to configure that variable and how to run the binary. So now, having this compact path, what we are doing here basically is assigning to that variable the compact home environment that we already know where the compiler was installed. The second line of code important here, it's the child process. So what we are doing is we're creating a child process of our compiler, giving the path and giving the command to execute the binaries. So all this process, it's available by running the run compact C command. And since this is configured as a bin, all other workspaces that has this workspace as a dependency are going to be able to run this command. So let's take one of those other workspaces as an example. Let's take a look at the counter example, and let's go to the contract and let's open this package.json. So in here, we can see that it has a dependency, the compiler. So it's the Midnight Network Compact. So since this workspace has as dependency the compiler workspace, within the script, we want to be able to run the run compact C command defined under bin. Okay, perfect. So far we have learned everything about the libraries necessary. We have learned how to configure the compiler within the repository. So now we are ready to actually start developing a real Midnight smart contract. So we want to start this chapter by talking about the counter example, which is the first example that we're going to develop using Midnight. This example, it's simple, but it's going to introduce us to the basic concepts on how to develop these smart contracts. We're going to structure this chapter in 4 topics. the first topic, we're gonna talk about the language compact, which is where we actually write our logic for the smart contracts, and we're gonna learn how to compile it. Then we're gonna talk about oracles. This counterexample doesn't use 100% the features of private information. Nevertheless, we're gonna learn where to configure oracles when it's necessary. On topic number 3, we are gonna actually use the APIs that we mentioned that are provided by the Midnight team, and how we use them to write our logic to talk with the compact output and the different instances. And then on topic number 4, we're gonna develop a TUI, which is a UI based on text to interact with the smart contract that we develop using these after developing these first 3 topics. So let's do it. Okay, now let's talk about the compact language. We have already mentioned compact, compilers, where to install the compiler, the binaries, but we've never mentioned what is the compact language for, right? So compact, it's considered a DSL, domain specific language. So what you write actually, it's the smart contract code, it's using compact. So you write your code here, and then you compile it, and as an output, you have TypeScript or JavaScript, and you have a code here in TypeScript. So you might have a question like, why don't we just write our code using TypeScript in the first place, and we have to use compact? So DSLs, the purpose of them, it's make our life easier. These DSLs provide APIs and functions specific to do something in a really efficient and easy way. So we can write a smart contracts using these APIs, and then compile it and have an output in TypeScript. If we would have to write our contracts directly using TypeScript, that would be much harder. So that's why we have this DSL. So if we see the code, right, where is in our contract, we are in the examples. We go to the folder examples. We have these 2, bulletin board and counter. We're gonna see first this first example, counter. Inside, we have the counter CLI folder and the contract. This one here, the CLI, it's where the APIs and functions reside. We're gonna take a look at that later. We first let's see the contract folder, where is our contract and the oracle. We go under source. This is where all our logic it's written. The files where we write compact has extension .compact. So if we click in here, this is actually the code written in compact, right? Before understanding this code, I want to show you guys that in the Midnight docs, this is gonna be our best friend. This is where all the documentation regarding the APIs and compact language resides. So if we go in these docs under the compact language folder, in here we're gonna see all documentation regarding the compact APIs and how to write the code, right? So we're gonna use it a lot because the APIs are changing all the time. So we have to reference this documentation to make sure that we are in the correct path and that we are using updated information to write our smart contracts. Now we are ready to start building our first smart contract and to compile it. We are gonna do the control compact example. But first, let's understand what is the program that we actually want to do, what we want to accomplish. So for this, let's design a small schematic here. So what we want to achieve is we want to have a counter, right? That its value is going to be 0 at the beginning, And then when somebody executes a command, we want to increment that value in 1. So now the value of the counter is 1. If a new command executes, then the new value of counter goes to 2. If another command is executed, then the value of counter it's incremented, and the new value is 3. So that's what we want to accomplish. Okay, this was just for a generic overview, but let's design this in a more appropriate way that is gonna make our life easier when we are designing smart contracts in Midnight. So for this, let's erase this, and then we're gonna structure this in 2 parts. The first part we're gonna call the private part, and the right part we're gonna call it the public part, right? The in the private part we're gonna have the witness. In the public we're gonna have the ledger. So if we take a look at the code, the counter, we don't have any witness, but for the public part we have a ledger. How we define it? So we do export ledger. Ledger is a command to define ledger. And we're gonna define our first ledger variable, which we're gonna call it round. And we're gonna define the types. But before going that, let's finish our schematic. So we have a private and a public, right? In the ledger, we're gonna have a variable, right? That we're gonna have our counter. It's gonna start its initial value is gonna be 0. And then in the private part, we are not gonna have any witness, right? Nevertheless, to execute something on the ledger, we need to perform an action. This action, it's called a circuit. So in our code, we see that we are defining one circuit. So we do export circuit. The name of our function or circuit is going to be increment. The syntaxis, it's very similar to TypeScript. So in this case, this means the output of this function circuit, it's going to be null. There's not going to be any output. And what we're going to perform inside this circuit is going to be round increment. So we're going to increment by 1 this value. How do I know that I have to define the counter? How do I know this method? So for that, we have the documentations of Midnight. So let's take a look. If we go to the documentation of Midnight, in the compact language, we can see here that we have ledger data types. On the left, we can see all the types available for ledger data types definitions. So we have kernel, we have cell, we have counter, we have set, we have map, we have list, we have Merkle tree, we have historic Merkle tree. We're gonna see in detail each of these types when we start developing other smart contracts, but for this one, let's take a closer look at the counter type, since I think that one is gonna solve our problem. So let's take a look here at the counter. Let's find it. Okay, we have the counter here, and we can see that we have different methods for this a kind of type in the ledger. We can decrement, we can increment, less than, read, reset to default. So this one is what we want, right? To increment. Increment the counter by the given amount. So we define the method increment, and then we pass an amount. So if we go to our code, we can see here, right? We in the ledger, we're gonna define a variable called round that is gonna type counter. And in the function circuit that we call increment, we're gonna call this variable round, and since it has the type of counter, we have this method available, increment, and we want to increment by 1. So in this way, we have the ledger and we have the circuits, and we can increment its value by 1 every time we call the circuit. Perfect. So with that, we have our contract. Let's take a look at these two first line of codes. This second one, import compact standard library, it's a conjunctions of functions and abstractions that we can use to facilitate when we are writing our logic using compact. What are the functions available within this compact standard library right now? If we go again to the docs, we can see here that we have a compact standard library. And we can see here all the functions that we have available right now to use within our circuits. So again, we're gonna take a look at those when we need in the future, when we are developing the smart contracts. In this contract, we are not using none of them. Nevertheless, it was included just for reference. See, we can see here that we have different other functions and variables that we can use. In the future, the idea is that this library right now it's provided by the Midnight team, but in the future, community will build their own libraries and make it open source, so everybody can import some third-party libraries and use them as any package in TypeScript, for example, like npm, for example. In this first line of code, what we are saying to Compact is that we are going to use version 0.14 of the Compact language. Okay, so with that, we have see all these 10 lines of code when we are writing a Compact contract. But we mentioned that we have a compiler, right? We have a Compact language and we have the compiler. When we compile this code, what is the output? So if we go here to the code, we can see that we have a file called managed counter. If we go inside that file, we're going to see other 4 files. So those are actually the output of the compiler after running this smart contract. So let's take a look what's inside. Inside compiler, we can see here a JSON that can be seen as a blueprint of our contract. We can see here that we have a circuit that is named increment, which is the circuit that we have, and it's not pure equal false. So in the future, we're going to learn that we have pure and impure circuits. In this case, our circuit is not pure because we're using a ledger data type within the circuit. Okay, let's see another file, contract. In here, we have the JavaScript of our code. So index common.js, let's open it. So remember that I mentioned that a DSL is basically used to write codes in a more efficient way using specific APIs. If we had to write our contract without using Compact, and we would use entirely JavaScript, this would be the result. So if you see here, this is pretty much 208 lines of code that we don't have to write since it's the output of the compiler. So we just write these 10 lines of code and we have this as a result. Pretty neat, right? So, well, that's the output of the CHS, common.js, and we're gonna use it then to write our smart contracts, but we don't have to write it ourselves. We just compile it. We get this output from the compiler. Then we have the index DCTS that are the types. I'm gonna open here so you can see better. We have the types of the contract. So we have the types for our witness. In this case, we don't have any witness. We have the types for our circuits. We have impure circuits and pure circuits. We saw that we don't have any pure. We have impure circuits that is called increment. This is a type definition. We have a type definition of our ledger that we have a round. And then we have it, the definition of our class construct. We are going to use this in the future to write our APIs and talk with the construct. Okay, and the other two files that we have are keys and CKIRs. What are those? If we take a look inside keys, we're going to see that we have, it's just a binary. We don't get to see what is inside. Actually, we can see, but there's just there's no value information inside for us to see, right? But we're gonna explain why these keys are important. And the CKIR, we can see one of them, which is a JSON that represents a CKR, which is zero knowledge intermediate representation. So I'm going to explain what are the purpose of these two files within a smart contract. So if we go to here to our example, I'm going to use now this blue. So we have a CK IRs and we have our keys, right? So what happens in Midnight is that these circuits will write code, but what we actually send to the blockchain within that circuit, that command, it's a proof, right? So the user who sends the proof, it's called a prover. And the person or the system, in this case the blockchain, that is going to receive the proof, it's called a verifier. So what happens here? When the prover sends the proof, the verifier checks that the proof is okay for the counter to be incremented with the circuit. So this is what happens in real life. So these CKIRs and keys are used for the prover to create the proof, and the verifier also have its keys to verify the circuit. So, and the CKIRs are specific for the circuit. So in this circuit, we have a CKIR. So if we take if we see the code here, for the keys, we have a key for the prover, and we have a key for the verifier. And for the CKIRs, we have one for each circuit. In this case, we only have one circuit, which is increment. Okay, perfect. So now let's learn how to compile our code. We have already seen that we have the output, right? So let's see what happens if I erase the output. So I don't have the output of my counter example. So how do I create it again, right? How do I compile it? So if we go to package.json, we can see that we have some scripts, and one of those are compact. So we're gonna use this command, run compact C, that we learned before how to build it, right? It's a workspace that we have. And this is the command to execute the compiler. As an input, we're gonna have the control compact, which is our code that we just learned. And as output, we're gonna paste that in a file called managed control. So to run this, we have the command compact. So we just have to write yarn compact, and that's it. Let's do it. If we open the CLI, we have to be under the contract folder. Okay, so make sure you are under this contract folder, and now let's just run yarn compact. So we can see that the compiler started to work. It compiled. For each circuit, we get a pair of values, k and rows. We have only one circuit, so we have only one pair. And here on the left, we see that a file manage was created. If we go inside, we can see that we have the outputs of the compact of the contract again. Okay, perfect. So we just learned how to compile our contract, right? Let's talk now about oracles, which is our private information. For oracles in Midnight, we want to have to understand two things. First, two things. First, we have to know what are going to be the types of our private information. And then we have to define what is going to be the structure of our oracle. So if we put this in the structure that I was using before, the way that I like to think about when I'm building smart contracts in Midnight, we can divide our logic in a private part and a public part. Here is where our private information resides, and the public, we have our ledger, right? To talk between them, we use circuits. And within the circuits, it's where we define our logic, which then it's transformed into a CK, right? So what happens now? Within that circuits, besides logic, we can now take this private information and use it within circuits without exposing the private information into the ledger, the public. And also, we can change our private information back. So that's gonna be really handy. But in our case, in the Oracle smart contract, we don't have private information. If we open the smart contract of the counter, we can see that we have a ledger, we have a circuit, but we don't have a witness variable. So we don't have to define any witness since we are not using witness for this type of contract. Nevertheless, we still have to define the basic structure of a oracle, which is a empty object. So if we go to witnesses, this is where we define our oracle. So I mentioned, right, that we have to define the type of our private information and the oracle. In this case, since we don't have any, the type of our private information, it's going to be an empty object. In TypeScript, to define that, we use record string never. And in the case of our autocall, it's gonna be, we're gonna call it witnesses, and it's gonna be a empty object. Perfect. So now we have defined our contract. We have defined our witness, and we have compiled it. But there is one important thing that we haven't mentioned, and it's really handy when we are building smart contracts or any code at all. For example, in TypeScript, if you write code a function, you probably use console log, right, to observe what is the output of a function and make sure that your logic is working correctly. So how do you do that in Compact? There is a way that we can do that without having to initialize the instances of Midnight, meaning the proof server or the indexer or the node. We can just test the logic using code. So if we go to this file named test, this is where we're gonna define the structure, how we test our contract. Inside the test, we're gonna have two files. One, it's a class that we're gonna define contract simulator. This is where we're gonna define our methods for testing the contract. And the other file, it's where we actually gonna test the logic of our smart contract. Let's take a look at the declaration of the class. We're gonna just take a look in a macro perspective. In future contracts, we're gonna all the time use these test simulators. So you're gonna get a better grasp of it as we go, right? So just let's start with a simple example. So in this case, we are declaring a class named contract simulator. We're gonna have two variables, contract and circuit context. What is contract? It is gonna have type contract. Where I'm getting that at? If we get over here, we can see that a contract, it's coming from the output of the compiler. So just to remember what we did before, if we go to manage, which is the output of the compiler, we got these four files, right? Inside contract, we get the output in JS and the types. If we get into the index JavaScript, we can see that here we have a class named contract. So we're using that contract. And then in here, we have all the types. So let's go back to our simulator. We are defining contract as the contract class, right? Passing this type, contract private state, that if we see here, it's coming from our witness that we just defined. And then we have another variable called circuit context that it's of type circuit context. This one is coming from the Midnight SDK, the compact runtime. Okay, so now we initialize contract with a new instance of that class, contract. And circuit context, we initialize it with some other variables. Where we get these variables from? It's from calling our instance of the contract and applying the method initial state. So in this way, we simulate the flow of our contract without having to use the instances. And then we define three methods. One is called getLedger, where we get a variable from the circuit context that we just defined over here. And this is where we're gonna get the actual state of our contract. Then we have a method called getPrivateState. Again, we grab that information from the circuit context, point current private state. So this is gonna be the private state at this moment when we call that function, that method. And then we have another method, increment. So in this case, we're using the instance of the class and we have methods. One of those is impure circuits. And we can call the circuit increment. So if we remember our contract, we have one circuit called increment. So if we go to the simulator, we can we have the circuit available, right, from the impure circuit. So we have, so now we get the we return the state. So perfect. So in this way, we define the class for our simulator. So now we're going to use that class to actually define the test that we want to run to make sure that our logic is working correctly. We are going to perform 3 tests. The first one, it's we are initializing the instances of our simulator, simulator 0 and simulator 1. And what we are doing here is we are comparing that the state at the ledger after initializing the contract for both simulators are the same, which should happen since we are using the same blueprint of the contract, so the state should be equal. In the second test, we're initializing the simulator and we are obtaining the value of the ledger of that contract after initializing the contract, and we are comparing the variable round to be equal to 0. What happens if we go to the contract? The only variable that we have in the ledger is called round, and it's type counter. In this case, since we haven't changed that value when somebody initializes that contract, it should be 0. You can change that value if you put that logic within the contract, but if you just leave it as default, these types, for example, counter, it has a default value. In this case, for counter, it's 0. So that's why we are making sure that the default value of round should be equal to 0. Then we get the private state, and this value should be equal to an object, an empty object. Why? Because that's what we define. And then the other test, we're initializing the simulator, and now we are applying a circuit. We have the method increment. So after applying that circuit, we want to make sure that our variable round, now it's equal to 1. Why? Because in our circuit, we have actually defined that after running this circuit, our variable round should be incremented by 1. So we are making sure here that after performing this circuit, our new value of round is equal to 1. And then we're getting the private state and making sure that the value of our private state is an empty object because we haven't changed it during the circuit implementation and execution. Perfect. So now, how do we run this? If we go to package.json, we can see that we have a method called test. So we can run this command to actually execute the test. So now let's just run yarn test. We have to make sure that we are under the contract folder. So examples, counter, contract, and we can run yarn test. It's running. Perfect. We have executed these 3 tests, and all these 3 tests have passed, right? So now we are sure that the logic of our contract is actually what we want. So now we just have to build the contract with the witness. For that, we use yarn build, and we should have created this folder called dist, where we have all the output. So this is all for this first part of the episode 2, understand the code. So let's summarize what we have learned so far. We have taken a look of what is the repo architecture. We have understood what is the compiler wrapper, and we have started to see the counter example. So let's see the topics. In the first chapter, repo architecture, we went through what is Monorepo workspaces. We understood what is a turbo repo for, what is used for in workspaces, how all these connect together. We understood what are the midnight packages, and we have seen some technologies that we're going to use in our code, like RxJs and test containers. Then we saw within the Repo architecture how we define the compiler within the workspace structure. And then we started to understand the counter example. We started taking a look at the compact contract. We took a look at how we define the oracle, and then once we wrote this code, we learned as well how to test our smart contract logic and how to build, right? For the second part of this episode, we are gonna start to learn how to define our contract using the APIs, so we can run the contract using the actual instances of Midnight, like indexer, proof server, the nodes, and then we're gonna run that, and with that we're gonna create a class, so we can use the methods of this class to actually run a TUI, which is a text-based user interface, to actually run our code in a TUI. Then, with that background knowledge, we're gonna start to take a look at a more difficult contract, which is the bulletin board, and we're gonna follow the same procedure. First, we're gonna start learning how the compact contract was written. Then we're gonna define the oracle, and we're gonna test it. We're gonna test our logic, and we're gonna build it, and we're gonna compile it. Then we're gonna define the class of this contract using the APIs to interact with the instances. And we're gonna test that contract using a TUI, but also for this example, we're gonna build a UI. So we actually gonna see the execution of the contract in a user interface. Well, this is all for this part 1. Coming next is gonna be part 2 with this content that it's pending. So see you all next time. Bye bye.